Welcome back. Here we are. I see 3 people. But we are back, ladies and gentlemen. It's Tuesday, February 16th. Long weekend. I see you all there. Thank you for leaving your comments. If you haven't already, please make sure that you leave a comment in the chat. That would be wonderful. Sometimes I feel like when I'm doing these introductions with the microphone and there's nobody in the classroom, I feel like I'm hosting a late night show. And I'm kind of like, doing like the opening monologue. I'm like, what's in the news? What's in the news kind of thing, And then I say my jokes and then everyone gives like polite applause because the jokes are kind of like passe. And then I'm like, all right. And then I'm like, band, play me out. And then I, band music plays and I walk over to the desk and I begin my lesson. Anyway, I have tons of things for you to do today. I'm so excited. I see that the number of people in the chat has fluctuated from like 4 to 7 to 8 down to 3 and 4 again. Oh, well. Here's the general plan. I have some practice problems that I would like you to try, but they come with a twist. They come with a little bit of a twist. And I'll explain what that twist is as we move throughout this class period. I'm going to tell you that we are headed towards a major assessment. We are headed towards a major assessment. Now, how that's going to happen, of course, typically how I like to do that, it's going to be electronically, like we've done in the past. But with that major assessment, I am going to be reviewing most of the chapter with you guys on Thursday. I would like to review the chapter, and then we'll be able to knock out this major over the course of the weekend. I do have other assignments that I'm going to throw at you. Stay tuned to Google Classroom. But that's my generalized plan. As for today, what I have for you today is a choice. But this choice, obviously, you're going to have to stay with me in this little live stream we got going on here. What is that? Someone's got to change their username. Anyway, the choice that you guys have is this. I am going to give you 2 sets of problems. And you are going to choose what path you take. You could either, if you feel like, I need some more help, I need some more guidance, then yes, by all means, stick with me because I am going to be going through one of those sets of problems. But if you feel like, you know what, I got this, I feel like I can do this, you can work on the other set of problems. Let me show you visually so you can kind of see what's going on here. First and foremost, in your Google Classroom, and I'm going to bring your attention to that in a moment, right there. If you go to the stream on February 11th, last Thursday, I posted the following worksheet. So it's still in your stream under February 11th. And by all means, yes, I'm going to be working off of this worksheet today, so you don't have to squint at the screen and see what problems I want you to do. These are the problems I want you to do. So please make sure that you can access that PDF from the Google Classroom stream. But comes with a twist, like I said. And here is that twist. Now, I'm going to suggest that you take a moment right now and copy down these problem numbers regardless. Copy down these problem numbers regardless. Because, well, once I get started, I am going to be working through numbers 2, 6, 11, 16, 21, and 22. So if you're someone who's like, I need a little extra help, I need to be guided through this a little bit more, then you stick with me and I'm going to be working through these 6 problems. But if you feel like I can do this, I think I can do this, I think I can handle this, then you're going to stay on the live stream, of course, but you're going to work through these 6 problems. Now, after I am done working through the original 6 right here, the ones that people are doing with me, they can ask questions if need be, etc. After I'm done there, I'm not going to go over all 6 of these, but I am going to go through at least a couple of them to show you, yeah, you did these right, or this is where you screwed up kind of situation. So if you would, if you do not already have them out, if you have not already copied down these problem numbers, because I'm going to take this page down in a moment, I'm going to need those notebooks out and open. That's when the band plays, and then I walk over to my desk. That's my theme song. And then everyone's like, yeah. And then I go through the first sketch or I bring up the first guest. I don't know exactly how it works. Not that I've hosted my own show before. Okay. So like I said, each of these problems are off of that worksheet that is in the Google Classroom stream right here. I'm going to begin working on numbers 2, 6, 11, 16, 21, and 22. Again, if you are someone who feels like you can do this, stay on the live stream, of course, because I'm going to be going through some other, a couple of your problems a little bit later on. But if you have any questions, of course, I have the live stream open up in front of me. You can see that right there. There's the live stream open up in front of me. Let's go. So I'm going to move this. Make sure you've had those copied down because those are the problems you're doing. Let's go. So let's start with number 2. In terms of notes, I want to make sure that we at least have a title for this. So I'm going to call this Solving Radicals Practice. Can't see what I'm writing, so there it is. Solving Radicals Practice. And today is the 16th. Now, number 2 on this particular worksheet, 2x to the 3/4 plus 7 equals 23. Now, a couple of reminders from last week. I should move that up a little bit so you can see the equals. There it is. A couple of reminders from last week. Last week, I reminded you of what you've been taught in the past. You have been taught PEMDAS, which is great. PEMDAS is good. But you have to know when PEMDAS applies. PEMDAS applies when you are evaluating expressions, when you are simplifying answers. That's when PEMDAS applies. I introduced to you the concept of SADMEP. Now, SADMEP is when you are solving equations. When you are solving equations like the one that you have in front of you, typically you have to take care of any outside addition, subtraction first. Then you take care of any outside multiplication, division. Then you take care of any exponents that are left on the problem. And then finally, if you have any parentheses, you deal with them last. That is the concept of SADMEP. It allows you to solve equations by taking PEMDAS backwards. logically, the first thing that you should do is subtract 7. So that's literally what I'm going to do. I'm going to subtract 7 here. No, it's not 23 anymore. It's a 16. Good for it. So I got to solve this thing. What's going on here? I don't know. Well, I've taken care of any addition, subtraction. Now I got to see if there's any multiplication, division, which there is. I got to divide by 2. If I divide both sides by 2, I am left with the following. Fine. Okay. Again, there have been no parentheses on the problem, but now I got to deal with exponents. Exponents is the last thing I got to do before I get this x by itself. And what I showed you to do last week was I'm going to raise to the power of the reciprocal. I am going to raise to the power of the reciprocal. Now, what this does when I raise a power to a power, it forces me to multiply the two exponents together. And when I multiply 3 over 4 times 4 over 3, they cancel each other out. Great. Oh, I forgot one thing. Whatever I do to one side, I have to do to the other. Raising both sides to the 4 over 3 power. Again, whatever you do to one side, you have to do to the other. On the left side, they cancel. Good for me. Leaving me with x equals. On the right side, I'm going to have to evaluate this thing in a moment. Oh. Now, let me remind you of something from last week. Last week, I gave you a statement that I put a star on. And whenever I put a star, you better believe it's important. But it basically said that you have to put in a plus or minus if you introduce an even root to the problem. Now, guess what? You introduced a root to the problem. Power over root. You introduced a root to the problem. But it was an odd root. And because it was an odd root that you introduced to the problem, you don't need a plus or minus. You always have to check to see if that's the case. Check to see if you need to include a plus or minus in the problem. But in this case, you don't, because it was an odd root that you introduced. So instead, I am going to evaluate the problem using that process of power over root. The third root of 8, you should know, is 2. 2 times 2 times 2. And 2 to the 4th power is 16, which is the answer. Now, I'm going to double check my answer because, of course, you must always check for extraneous solutions, as we talked about last week. But checking just involves plugging it back in and making sure that it works. Again, I just followed SADMAP. Let's see what happens. Now, when I plug this 16 into the problem, when I plug this 16 in right where my pen is pointing, you better believe that now I have to follow PEMDAS. Because when you plug something back in and simplify or evaluate, then you have to follow the order of operations, PEMDAS. If I plug that 16 in, I have to evaluate the exponent first. The 4th root of 16 is 2. 2 cubed is 8. 8 times 2 is 16. 16 plus 7 is 23. It works. it works. Now, I know I had a few people come in late into the chat. Just for the sake of argument, I'm going to bring this back just so everyone can see it one more time. My plan for today is this. If you feel like you need extra practice and extra help on these problems, I am going through the 6 problems on the left, and you can do that with me. Or if you feel like you have a grasp on the situation and you feel like you can handle these problems on your own, then by all means, do these problems. I'm going to remove this paper in a moment, giving you an opportunity to write this thing down. And we'll see what happens. Oh, snap. Give me 1 second. I have to check one very important thing. Okay. Well, that's a problem. Give me 1 second. I just have to send a quick message. Well, there we go. Okay. I'll explain to you exactly what just happened. While I am teaching, I have the live stream open on my phone so that I can see your questions and comments if you have any there. And a direct result of that is I know when I get a message from a text message or whatever, or an email. And I got a text message from my wife that simply said, "Do you have my keys?" And I went to go check, and yes, I have my wife's keys. And she needs to go pick up stuff today. Oh, it's funny. I can't do anything about it. I'm here. I guess we'll find out what happens. Oh, fun stuff. I'm here for another 40 minutes. So we'll see how that goes. Oh, life problems. Anyway, back to this. Let's continue working. So let's take a look at number 6. As I said, if you're working with me, we're going through these problems. If you are working on your own, I will go over a couple of those near the end. So number 6. 2x to the 5/3 equals negative 64. Now again, I consider the SATMAP. The first thing I try to do is I try to see, are there any parentheses? And in this case, no, there's not. There's no parentheses. If you had a radical symbol, then you could assume that there were parentheses around that, but nothing yet. There's no addition, subtraction. Okay. Let's do multiplication, division. I got to divide by 2 first. If you divide by 2, you end up with the following. Now, I'm going to remind you of how to do certain things on your calculator in a moment. But let's just see what happens here. To get x by itself, I'm going to raise both sides to the power of the reciprocal. There we go. Oh, both sides. Both sides. There we go. Oh, happy day. Because raising it to the power of the reciprocal, power of a power, you end up multiplying these two together and they end up canceling each other out. Oh, Lindsay, I was going to say why I asked you guys to do was to choose one column or the other. If you chose the first column, I would go through those problems with you. You can totally do both if you want. Kelsey, I just saw your comment there too. But if you wanted to try these problems on your own, you totally can. I gave you a separate column that you could work on. So it's completely your choice today what you do. You can follow along with me, or you can try those problems on your own. I'm not requiring you to do both columns of problems. I was just saying, here's a column of problems that you can work on in the meantime. No. You don't have to have done both. I just wanted you to be able to step up to the level that you believe that you're at. If you felt like you needed a little extra guidance from me, or if you felt like you could handle these problems on your own. That's what I really wanted you to determine for yourself. No, you're not turning then. This is for your notes, for your own edification. So from here, I have to figure out the fifth root of negative 32 to the third power. Now, here's the issue. I know what the fifth root of negative 32 is off the top of my head, but not many people do. Not many people do. And I would like to see a progression of work or an explanation, because you do know that in a lot of the problems that I give you, I do require explaining what each, sometimes what you have to do in order to get a problem done. You've seen that on some of my edge elastic assessments. So I got to do the fifth root of this problem. And then eventually I'll cube it. Let's go to the calculator. If I go to my calculator, where you want to go is you hit the math button, and then you go down to the fifth option, which is the x root. You can type in a 5 to be the fifth root. And now I got to type in negative 32. Now be careful, because you can't put in minus. You have to put a negative sign. And that will tell you what the fifth root of negative 32 should be. And this should make sense because, well, negative 2 raised to the fifth power is negative 32. Now, what that means for us on paper is this. That fifth root of negative 32 turned into a negative 2, and now I just have to cube it. Negative 2 times negative 2 times negative 2 gives you negative 8, which of course we'll double check in a moment. At no point did I introduce an even root. In fact, I didn't introduce any root. Ms. Markey, you wrote it there. No, I didn't introduce that root. Actually, no, I did introduce a fifth root. Blast. I contradicted myself. But yeah, there was already a third root on the problem. And technically, yes, I did introduce a root, but I introduced an odd root. And because I introduced an odd root, I do not need a plus or minus. Only when you introduce an even root. Interesting. I could plug that 8 back in, or that negative 8. The cube root of negative 8 is negative 2. Negative 2 to the fifth power is negative 32. Negative 32 times 2 is negative 64. It works. Let's take a look at another one. I'm looking at number 11. I'm going to write down number 11, and then I am going to type out an apology text to my wife. There we go. Let me do that. There we go. Apology sent. I'm probably going to pay for it later. Well, let's just see what happens. Now, for this problem, I want to be very clear about something. Yes, there is a 3 in front of the radical, but that 3 does not indicate that it is a cubed root. That 3 is simply multiplying by the root. And since there is no little number in that crevice, you have to assume that it is a square root. So this is actually 3 times the square root of x plus 6. Now, I made a little mistake drawing my little radical symbol here. I made it a little bit too long. That plus 5 is on the outside. Please make sure you recognize the fact that that 5 is on the outside. Now, this is the problem as written on the page, but I'm going to add in one more thing. You have to assume that there are parentheses surrounding that x plus 6, meaning you can't touch that 6 until you get to the inside of that radical. So here we go. SADMEP. I got to take care of addition, subtraction first. So I'm going to subtract that 5. I took care of the addition, subtraction. I take care of parentheses last. Now I got to deal with multiplication, division. I got to divide by 3 because that 3 is not on the root. That 3 is being multiplied by the radical. If I divide by 3, I get the following. Now I'm at the radical. It's a square root. I can square to get rid of it. Okay, if I square it, I get to the inside of that radical and I get to the x plus 6. If I square one side, I have to square the other. But once I get to the inside of that radical, technically the parentheses go away. And now I'm just left with a pre-algebra problem. X equals 3. And now this works. This totally works. Again, I'm going to check my answer in a moment, but this is the process that you would have to go through. I'm going to take that 3. I'm going to plug it back in. 3 plus 6 is 9. Square root of 9 is 3. 3 times 3 is 9. 9 plus 5 is 14. It works. The reason why I am checking all of my answers is because if at some point it doesn't work, then either you made a mistake or your answer is extraneous. And typically you'll know it's extraneous if you get an answer like 1 equals -1 or 10 equals -10 or some junk like that. If it's something like that, then you're like, ooh, is this extraneous? Then yeah, probably it is. That phantom limb of an answer. Let's look at number 16. Number 16 was the 5th root of 3 minus x plus 4 equals 3. So I'm looking at this problem. And again, I got to deal with SADMEP. Now, mind you, that 3 minus x, that 3 minus x is on the inside of the radical. As a result, I have to assume that there are parentheses. Oh, my wife just texted me back. I'm going to fill you in on my marital issues. She says, no problem. And then she asks if I can talk. I can talk at 10:30. There we go. Crazy times. Anyway, you have to assume parentheses around the 3 minus x. I'm going to subtract 4 to start the problem. The fifth root of 3 minus x is actually equal to -1 after I subtract that 4. Now I got to raise both sides to the 5th power. Okay. See how that works. Raising it to the 5th power will get rid of that 5th root. But here's the thing that I want you to recognize. First of all, on the left side, the radical goes away and you're just left with the 3 minus x. Yes, there are parentheses there, but once you get to the inside, the parentheses kind of drop. -1 to the 5th power. I need you to be very careful. It's just -1. When you raise a -1 to a power, you have to know whether or not it's an odd power or an even power. And in this case, you are raising it to an odd power, which means there's an odd number of negatives being multiplied together. If it were an even number, then that negative would turn positive. But since it's an odd number, that negative stays negative. Please be careful. The next thing you got to be careful with is what we have here. 3 minus x. Be careful. I have a lot of people tell me, oh, add 3. No, you can't add 3. Why not? It's a minus sign. Yeah, I know, but that minus sign is on the x, not the 3. That 3 is positive, meaning you have to subtract 3. -x equals -4. And once you get that -4, and that negative is still on the x, now you can divide by -1. And dividing by -1 will give you this +4. You have to get the practice going through SADMAP. You have to take care of the proper operations first. Plug that thing back in. 3 minus 4 is -1. Ah, the 5th root of -1? Yeah, the 5th root of -1. Check this out. The 5th root of -1. Any odd root of a negative stays negative. Any odd root of a negative, you can assume it's an odd root of a -1. Take that -1 out, as we've done in the past. Then, -1 plus 4 is +3. All right. Now, as I've stated, I got a couple more problems to do for those who have been working with me. But those who have been working with me have been working through the problems on the left. And the people who have been working on their own have been working on the problems on the right. After I go over the next 2 problems, I am going to be taking questions from those who did these on their own. I do have a couple that I'm going to try to go over with you, but if you have any specific questions, I want to answer those first. But let's finish up with 21 and 22. So let's see. 21. The 4th root of 2x plus 1 equals the 4th root of x plus 6. That's weird. They both have a 4th root on them. And there's x's on both sides. Ooh. Yes, but recognize the fact that there are parentheses around here. And the outside layer on both sides of the problem is a 4th root. Meaning, you can raise both sides of the problem to the 4th power. And as a result of raising both sides to the 4th power, you are left with this. Oh, happy day. Now, again, you're back in pre-algebra. Subtract x, subtract 1, subtract 1. You're left with x equals 5. Cool. Yeah, cool. Literally, that's all you have to do for this problem. The next one's not going to be so nice. But again, I can plug this 5 back in. I get the 4th root of 11, which is a decimal. But on the other side, I get the 4th root of 11, which is the same decimal. So it works. Sometimes the problems can be this simple, but you have to recognize when you can and can't do stuff like this. Let's take a look at number 22. And number 22 is going to be a bit of a beast. The square root of x plus 2 equals x plus 2. Now, it seems straightforward enough, but it isn't. See, on the left side, I have this x plus 2, but it's stuck inside a set of parentheses. On the right side, it's free to do whatever it wants. I would love to just get rid of the radical and see where the problem leads us. All right. Let's square both sides. When you square the left side, the square root goes away, and you are left with x plus 2, meaning those parentheses have now dropped. Yay! On the right side, you have to square x plus 2. You are not allowed to distribute that exponent. You are not allowed. You cannot say that the right side is x squared plus 4 because it's not. Instead, as I showed you last week, you are going to have to multiply out x plus 2 and x plus 2 in a 2x2 box, or FOIL, or distribution, whatever method you end up liking best. But you're going to have to multiply this out. And within this box, we get an x squared, a 2x, and a 4. Which gives me x squared plus 4x plus 4. See, the right side of that problem was not x squared plus 4. It was x squared plus 4x plus 4. And the only way you're going to know that is if you multiply out the box correctly. Please be careful. On the left side, I'm just going to bring down this x plus 2. And now I am back to quadratics. I'm literally back to quadratics. Solving quadratics. The thing that we all did in the beginning of the school year. The thing that I said that would come back and haunt you. We got to get one side equal to 0. I'm going to subtract x, and I'm going to subtract 2 from both sides, because you got to get one side equal to 0. Then I am going to factor using whatever method you were taught, Tucker method, grouping method. Some people like the whole X method, whatever they want to do. That's fine. That's totally fine. As long as it works. As long as it works. But this should factor into x plus 2 and x plus 1. 2 times 1, 2 plus 1. Move that up a little. If you set each of those terms equal to 0, you would get answers of -2 and -1. I'm not going to circle my answer just yet, because these are the types of problems that you may end up seeing extraneous solutions for. So I'm going to plug this, or plug each answer, I should say, back into the original to see if it works. So let's zoom in on this. If I plug in -2 in right here, I get the square root of 0, which is 0. If I plug in the same -2 right here, I get 0. -2 works. Aw, snap. I guess that means that -1 won't work. No, who said that? Sometimes it won't work. Sometimes it will work. Sometimes both answers won't work. The only way you're going to know is if you plug them back in. Let's take the -1. -1 plus 2 is 1. The square root of 1 is 1. -1 plus 2 is 1. Oh, 1 equals 1. Yeah. They both work. They both work as answers. This is the process that you would have to go through. So, those were the 6 problems that I wanted to go over with you. Before I take some of your questions from the other half, the ones that you tried on your own, and this message is for everybody, regardless of which set of problems you were working on. If you were working with me, if you were working on your own, the next thing you need to see and you need to write down. The very next thing that I am about to do, you need to see. This is a bonus. This is a bonus problem. And when I say bonus problem, I'm not saying it's not worth anything, but it's bonus in the sense that you haven't seen anything like it before. Mr. Markey, I'm pretty sure we've seen stuff like that before. No, you haven't. And I'll show you why in a moment. Kelsey, good question. Here's the thing. For problems like the one that we just did, number 22, sometimes both answers work and neither one is extraneous. Sometimes one of them will be extraneous. Sometimes both of them could be extraneous. That is a possibility, that both answers could just not work. The only way you're going to know, solve the problem like we just did and plug it back in. If it works, circle it and move on. If it doesn't work, you could label it as extraneous, but you just have to make sure that you didn't make a mistake. Typically, extraneous solutions will show up if it's like 3 equals -3 or 5 equals -5 or something like that. So the rule is not that one will work and one won't. That's not the rule. They both could. They both might not. Or you could get 1 and 1. You won't know until you plug them in and try. This problem. Bonus. You got to square both sides of the problem to start, just like normal. Okay, I'm going to square both sides. If I square both sides, I get a this. Cool. Now you got to get x by itself. Not cool. Maybe you should subtract 2x from both sides. What? I literally wrote the word what. both variables canceled out. Let me move that over so you can see it a little bit better. Both variables cancel out. What does this mean? Well, I guess I can't. Back in Algebra 1, you were faced with situations with a problem called a system of linear equations. And with a system of linear equations, you were trying to find a point of intersection, which is technically what we're trying to do here. But there were certain situations in which there was no point of intersection, or there were an infinite number of points of intersection. In this instance, when you have an impossible situation, 3 equals -1, that doesn't work. I know it doesn't work. Which is why your answer is no solution. This will only happen if all of the variables cancel out. Simply put, this will only happen if all of the variables cancel out like we just did here. Okay. Now, for the problems that you guys were doing on your own, you were doing numbers 4, 7, 12, 15, 20, and 25. I am more than happy to go over a few of them with you. I do have one that I want to start with. In the meantime, I'm going to start with number 4, just so you know, because I need to show you number 4. But after I show you number 4, if you have any specific requests, I would like to take those. Let's talk about number 4. Because number 4 is where something very interesting happens. And I gave this to you on purpose. Number 4 was parentheses x minus 1 to the 2/3 power equals 4. All right. Cool. Cool. Now what? Well, if I talk SADMAP, parentheses go last. So I can't touch that -1. I can't. All right. Any outside multiplication, division, or addition, subtraction? Nope. The outside layer is an exponent. Okay. I got to raise both sides to the reciprocal power. Okay. X minus 1 to the 2/3 to the 3/2 equals 4 to the 3/2. First thing I got to do is I got to raise both sides to the reciprocal power. On the left side, they cancel. Power of a power indicates that I multiply those exponents together. Oh, happy day. But on the right side, I did something. On the right side, I introduced a radical. Power over root. I introduced a second root, more specifically a square root, more specifically an even root. And because I introduced an even root, by definition, I need to have a plus or minus there. That plus or minus will play into the answer. So let's take it down step by step. On the left side, I'm just left with x minus 1 because now I've gotten to the inside of those parentheses. On the right side, I need to evaluate 4 to the 3 over 2 power. Notice how I wrote it. Notice how I wrote it. 3 over 2 power, power over root, third power, square root. Plus or minus, just coming down for the ride. So, my screen froze. There we go. Now it's better. Where was I? Right. Sorry, lost my train of thought. Square root of 4 is 2. 2 cubed is 8. So, when you get to this part, you may say to yourself, okay, my last step is to add 1. Yes and no. You are going to add 1. However, if you tell me that my answer is plus or minus 9, I'm going to flip out. Because that's not the answer. Plus or minus 9 is not the answer. You have to realize that, yes, you are adding 1. You are adding 1. But you're adding 1 to a positive 8 and a negative 8. Here's the proper way of going about it. After you add 1, you got to realize that it's going to be, again, the screen froze on me. Here we go. You have to realize that it's going to be a 1 plus 8 and a 1 minus 8. 1 plus 8 will get you 9. 1 minus 8 will get you negative 7. You need to be careful. You can check your answer. 9 minus 1 is 8. The cube root of 8 is 2. Squared is 4. Hey, it works. But you could also do it with the negative 7. Negative 7 minus 1 is negative 8. The cube root of negative 8 is negative 2. Uh-oh. But then you square the negative 2, and it gets you positive 4. Both answers work. Now, I'm going to go over one more problem with you guys. And I'm just going to not sweep through it quickly, but I am going to shorten my explanation of it. I'm going to talk about number 25. And then we'll wrap up with this. Number 25 is very similar to number 22. Except you got different numbers. You got to square both sides to start. When you square both sides, you end up with the following. But you have to multiply out in a box x plus 5 times x plus 5. Now, I've already done that. I'm going to bypass that, but you could either do that or you could FOIL, but you have to realize that it's x plus 5 times x plus 5. You can't distribute the exponent. You are only allowed to distribute that exponent if there's multiplication or division on the inside of the parentheses. It really should be 3x plus 13 equals x squared plus 10x plus 25. That is the proper way of looking at the problem. You have a quadratic. You got to get one side equal to 0. Subtract the 3x. Subtract the 13. Then you can factor. this is the quadratic that we got to solve. Magic numbers are 3 and 4. 3 times 4, 3 plus 4. Which give us answers of -3 and -4. Now, if you notice, I haven't circled them yet. These answers could work. They could not work. One of them could work. The other one might not. I don't know. The only way I'm going to know is if I actually plug them in. Now, to kind of backtrack to what we did last week, I showed you a situation where you had like some kind of a curve like this, and you only had like one answer. Well, there is a possibility of getting 2 answers. That possibility exists right here. Where that line crosses that curve twice. It can happen. It totally can happen. If I plug in that -3 right here, 3 times -3 is -9. -9 plus 13 is 4. Square root of 4 is 2. -3 plus 5 is 2. It works. Let's try the -4. -4 times 3 is -12. -12 plus 13 is 1. Square root of 1 is 1. -4 plus 5 is 1. It also works. You'll never know until you actually plug them in to try it. As I stated before, I am going to be throwing a major assessment at you before the end of this week. We're going to spend Thursday reviewing the chapter. It's going to be virtual again. I can't do anything about that. But we are going to spend Thursday reviewing the chapter. I may throw something at you in the meantime, just as a quick homework assignment. If you have not left a comment in the chat, as these people have so wonderfully done, please do so. That'd be fantastic. But in the meantime, ladies and gentlemen, I am out of time, and I'm going to let you go. So everyone take your stuff with you. Don't crowd in the hallway. I got to go call my wife and see what's going on. But yeah, that is the class period in about 2 seconds. So yay. Is the school still planning to reopen on the 19th? The 19th? Or did you mean the 22nd? I don't know. I assumed that we would be virtual all this week as well. I could have sworn. I'll have to check all those emails, but honestly, I have no idea. I'm assuming that all the students, well, not all the students, but students will be coming back on the 22nd, but I really don't know, unfortunately. It's a possibility. It could be the 19th, but no. I got to check all those emails. Usually I just delete them. But anyway, no, I don't just delete them. I'll check on that, but it shouldn't affect us because I would see you guys on Thursday regardless, and Thursday would be a virtual day regardless. The 18th would be Thursday. Yeah, and we'll go from there. Anyway, you guys have a great day. Website says the 19th. Now that's interesting. How many people are just not going to show up that day? I'm sorry. I got to get going. And you guys got to get going. You guys have a great day, and I'll see you another time.